Hello, in this video I'm gonna show you how to create a boost converter with Simulink. The boost converter regulates the DC output voltage at a level greater than the source voltage. For it, we need first a DC voltage source. We can choose, for example, 20 volts. Then we need an ideal switch. With a pulse generator for controlling the switch. So we can choose, for example, a duty cycle of 50% and a frequency of 20,000 Hz. Then we need a diode, and I will remove the diode losses. We also need an inductor, a capacitor, and a resistor. So first, the inductor, then a capacitor, and finally, a resistor. We can choose, for example, 10 ohms. I will also use two current measurements. One for the inductor, one for the diode, and I will use one voltage measurement for the output voltage. So at the resistor terminals, I will use the scope for displaying the signals. We have 4 signals. One for the pulses, one for the current through the inductor, one for the current through the diode, and one for the output voltage. We still have to connect the components together. And we still have to add the power grid block for solving the circuit. So I will show you first the continuous mode and then the discontinuous mode. For the continuous mode, the current through the inductor is always greater than 0. So I choose for the inductor this value, and for the capacitor this value. So we can run the circuit on a sample time of 0.2 seconds and run it. So here on the circuit, when the ideal switch is on, the load is disconnected to the source voltage because the diode will not let the current flow through it. When the ideal switch is off, the current flows through the diode and through the load. So we can display the signals. I will zoom in. So, when the interrupter is on, the current flows through it and the circuit is not connected because of the diode properties. The inductor restores some energy, and as we can see here, the diode doesn't let the current pass through it. When the interrupter is off, So in this case, the DC voltage source is connected to the circuit thanks to the diode, because there is a positive voltage between its terminals, and the energy stored in the inductor flows through the diode. So the currents are the same. In this mode, the output voltage is equal to the input voltage divided by 1 minus the duty cycle D. If now we reduce the value of the capacitor, we can see the output voltage is less smooth. If now we reduce the inductor value, the current through the inductor will reach 0 before the end of the period. That is how we can have the discontinuous mode. We increase the capacitor value for keeping the reduction of the ripple. If we zoom in, we can see the current through the inductor reaches 0 before the end of the period. In this case, the output voltage is equal to the input voltage multiplied by delta plus the duty cycle and divided by delta. And delta is the time required for the current for reaching 0 divided by the period. So, if we take the value for reaching 0, we have now the time for reaching 0, so we can compute the output voltage.